CRI to present our idea of to produce this low silica calcium oxide best state of art vertical line kiln. In paper industry, operations are very normal and conventional, and since long it has not been changed. And I think, and our team thinks that if we can bring some innovation, if not radical, at least incremental innovation must be carried out. If you see the Amazon company, so how actually it is reaping the benefit, because the material it is supplying to our houses. You will see you cannot purchase those material at those prices by your own locally. It is nothing but the supply chain. Same way in industry also we have to modify our supply chain. If we cannot change the supply chain entirely, we can break the supply chain also, if it is needed. This patent and this process describe a lot of things in similar way. I will explain you how. So, state of art vertical line kiln, actually why it is needed so? Every paper industry utilizes 500 kg to 700 kg calcium oxide per ton of paper production. Because it is needed not only in the recovery process plant, it needed in the other department also to produce hypo, to maintain the pH in ATP also. So calcium is the main, if you cannot say main, it is the important ingredient in the paper making. So, as I earlier told, it is the patented process. We have not implemented this technology as well. Definitely, we are in discussion with other mills also, and one of the paper industry has installed a vertical line kiln longer back. They may have failed because we also visited there and we saw the technology there, and it has some loopholes. What they were doing in that line kiln, they were sucking the flue gas from that and feeding it to the discharge end. Once, because we have to maintain the O2 in the exit of rotary line kiln also, or what type of line kiln also. Because if O2 is not there and O2 is decreasing less than 2%, the CO2 generated zone will react with the CaO, and again it will form the calcium carbonate. That was the lag in that. So how our line kiln or our state of vertical line kiln is different from that? Here we have to discuss. First, for the peoples, those who are not aware with the operations of rotary line kiln, so I just want to let them introduce this process, how does this process works, and how the operation of a simple line kiln works. This is nothing but a shaft shaft pipe, you can say, of diameter ranging from 3.2 diameter to up to 4 meter dia, and long as 100 meter. It rotates either in clockwise direction or anti-clockwise direction, ranging RPM 0.5 to 1 RPM.
Suraj,
So,
Suraj, presentation slide, you have to move.
why? So, please, can solve.
Okay, we can go back to the previous one.
So, this is the hopper where the mud filter scrap of mud and limestone comes in, and it by the feed through conveyor feed it at the feed end. The lime kiln actually, lime kiln's operation, if you will see, it is in the 4 zone. It is the drying zone, heating zone, calcination zone, then the cooling zone. So product finally is removed from the air. Here the burners firing is given by the furnace oil or natural methane gas, and many fuels can be added to reduce the fuel consumptions. But definitely flame intensity has to maintain. So usually they whole industry maintains this flame intensity by the primary air and secondary air. And so the furnace oil is the must is needed in the rotary lime kiln. This is the typically a stoichiometry of the limestone. If you want a very good quality calcium oxide, as Dixit ji has told, silica must be less. But this is the optimal. If this is the optimal, if you have a raw material mix 1% silica, it is good enough, because more pure is the raw material, most costlier it is. We have to compromise and have to come to extract where it is the optimal. This is the raw material mix. We have checked this. If you will see, the calcium carbonate is 97, means it is 97% pure. Remaining is the non-process, or you can say inerts. This is the reaction. If you have 100% pure calcium carbonate, the maximum purity 100% and maximum CO2 you can remove from it is 44 gram. But if your raw material is 97% pure, then the maximum purity you can draw from it 94.76. Take it 95. But 100% conversion is not recommended, because when you will go for the 100% conversion, there are chances that the silica which is in this system will bond with the calcium oxide and form the calcium carbonate. Even it may overburn. So there is a possibility, this is a maximum possibility of 95% purity, but practically you can draw a 90% purity by this raw material mix. And the third one, usually if you see, normally people don't produce lime purity as high as 90. If you observe the data across the industry, they are stable at the purity of 80 to 85% purity. If you are producing 80.5% purity, 80.5%, the fuel requirement will be 157.31 kilojoule for 100 gram. That means if you are producing a ton, the theoretical fuel requirement at 80% purity will be 2.57 kilojoule per ton, or you can say 60 kg of furnace oil, or you can say in terms of coal, 153 kg of the coal. This is the, if it has GCV of 4500. This is the fuel requirement. I am just bringing the stoichiometry actually, so that you can correlate at what efficiency rotary lime kiln is running. This is very important slide to understand and correlate. Why it is important? Unless someone understands this, someone cannot see what is the leeway of implementing the technology. If you see, usually if you see the supply chain of the lime, most of the lime is procured from the Rajasthan across the country. We are Indian, our company's main aim is first is to improve the operation of Indian paper industry. So, to produce a calcium oxide of 1 metric ton, it is required 1.6 ton of limestone. Usually, if you see from the supplier side, they purchase it in bulk. The cost of the limestone is 700 right now. It was 500 before Corona. It costs 1,120 rupees. Coal consumption, their lime kiln is totally different. Producing lime has two processes. One is a slow process and one is the fast. Our rotary lime kiln process has fast cooking. And once they fed all the material, coal and limestone, they leave it for the 3 days. Slowly it cooks. So coal requirement is, theoretical coal requirement is not theoretical, practical coal requirement. I already told you coal requirement is 153, but practically energy requirement is 4.22, 4.5 gigajoule per ton of CO. So 0.2 metric ton coal is required. This is the value. Power consumption, labor hours in terms of rupees. If you see the costing of lime produced is nowadays, it is 3,380 rupees. So supplier also gives this lime at the cost of some profit. So sale price of the lime becomes this much. At this much price, usually seller says, take this lime and you have to bear the GST and you have to bear the logistic cost also. So logistic cost usually across the 8,000 kilometer cost 2,500 rupees. And when the lime reaches to the mill, this lime has to be unloaded by the mill's level. And the cost of the lime becomes this much. So usually this is the rate. If you see the whole supply chain, the cost of the lime mill brought is 8,900 rupees, but it was produced at 3,300. Take it 3,500 even. So we see the 50% of the whole value is lost in the supply chain. So our caution and our discussion with you all is, because all are the technocrat and knowledgeable people, as Mr. M.K. Gupta ji also told, there is no dearth of knowledge in India. So this value can be saved, and this value per ton of paper contributes a lot. If they can produce it, we can also produce it. But we have changed the way we are doing it. This is the same thing. This is a rotary lime kiln, how it works. Usually it is in anti-clock direction, but it may be in clockwise direction also. If you see the bed, only I think more than 10% of the bed is not occupying the volume of this whole rotary lime kiln. Remaining whole lime kiln is packed, this blue portion. So only 10% is filled with calcium carbonate and CO. Out of the total circumference, only 10% is filled. There is a poor contact with flue gas and CO. So also there is a poor heat transfer coefficient, because the most of the heat, if you see, is getting lost by the surface area of rotary lime kiln as well as in the flue gases to dry the lime bed. Because as on average you see, the people have dryness of 60%. Those are very good. Those have very low silica. They are achieving dryness up to 75%, even 80%. They have optimized their fuel consumption up to 160 kg per ton of CO. Even if you calculate, this fuel consumption is still high, because our theoretical energy requirement is only 60 kg at 80% purity, and they are consuming 160 kg. If it is up to, if I am taking the 75% of the efficiency of the rotary lime kiln, it should not be more than 80 kg, 80 to 90 kg. So there is still lot of spark. This is the usage of the lime produced in the rotary lime kiln. And typically, data may be varies slight. The usually limestone makeup is 0.15, it's 150 kg per ton of CO. Furnace oil 120 kg. Some will have achieved some bit lower, but with the addition of some other fuel. This is the coal along with the furnace oil. So ultimate cost, if you see, if you reduce this makeup, because some mills are adding purchase lime also as a makeup. So overall costing is very, very high in the rotary lime kiln. And if you discuss with your colleague or any people, they will say rotary lime kiln usually don't have payback. But the time has come when we cannot put the cost of the rotary lime kiln to put in another pool. we have to think wisely how we can work on it. We can think and we can see lime mud as a waste, but it can be wealth. A rotary lime kiln has also a depreciation which never ever can be covered. And every investment we have made has some interest cost also. This is the efficiency of rotary lime kiln. So per ton, if you see rotary lime kiln, usually a typical fuel consumption in the vertical lime kiln is 4.2 to 4.5 gigajoule per ton of CO. And theoretical fuel consumption, if you see, already I have mentioned, and 80% purity is only 2.6 gigajoule per ton of CO. So what is the efficiency of rotary lime kiln? You can calculate. I have taken we have taken 4 gigajoule consumed as 100%, though it is not theoretical. So this lime kiln is running as low at efficiency at 34%. Means out of 100 we are getting only 34% marks. This is just the passing marks. Why it is happening so? There are huge radiation losses from the rotary lime kiln surface, can be as high as 5,000 to 6,000 watt per meter square of the surface area. There is also losses through the flue gas. It can be as high as 3.8 gigajoule per metric ton. It is actually more than the theoretical fuel requirement. This is the state-of-art particle lime introduction comes here. Actually, for the state-of-art vertical lime kiln, we thought to why this agro-based paper mill cannot run their lime kiln. Why they are so reluctant to run the lime kiln, and CPPB putting pressure on that because they cannot throw this lime throw the outside the mill, this lime because of the high silica content. They are unable to run the rotary lime kiln because their silica content are as high as from 5% to even 8%. And for the experiment of this, we had taken the mud of one of their agro-based paper mill. We can disclose the name of the mill, but silica content was 8%. By one stage centrifuge system, we have reduced the silica content to 3.5% in single stage. And our aim is to reduce the silica content to 1.5%. We know, we have a lot of discussion and research there, the density of calcium carbonate particles and density of silica is very close. But silica has some size more than the calcium carbonate particle, and we have been successful to reduce this silica content up to 3.5%. We are pretty sure even at 3.5% we can run the rotary lime kiln, no issue. Usually people are producing 80% purity. Even some of the mill has 3.5 to 4% silica. They are getting approximately 80% purity consistently. It is not dropping until unless they are reducing fuel consumption, because everybody is concerned about to optimize the fuel consumption. So one thing is clear: if we have to reduce the fuel consumption, we must have lesser moisture in the lime mud. And sometimes our nature is providing renewable sources of to get it dry without any cost. So our plan is why not to go for the vertical lime kiln. But in vertical lime kiln, we cannot directly feed the lime sludge. You have to compress the sludge into the pellet, because when you are want to run a rotary lime kiln, flue gas must pass through these materials. Even this vertical system can be integrated with rotary lime kiln. Usually in rotary lime kiln, it is, if you see the person who was working with the rotary lime kiln, they always keep the feed end temperature to 180 to 200. This is mandatory. If you are, we are thinking to reduce this temperature, purity gets drastically decreased. It was running 80%, and you will see some fuel has reduced, and IDFL has been, RPM has been reduced to keep the heat to the burning section. You will see the purity has drastically dropped. It goes down to 60% purity. Then it takes another 4 hours to bring to the 80% purity. In the rotary lime kiln, we are diluting white liquor clarifier or WLCD sludge to 10% and lower consistency. We feed to the sludge to a number of hydroclones, where are two outputs. One is upstream and then is downstream. Continuously from the downstream, a portion of the lime sludge is withdrawn to remove the silica, and the lighter particles are bring to the lime washer section. And by doing this, we have two streams. One is a high silica sludge stream, one is the low silica sludge stream. So from the mud washer last, we collect this lime sludge and compress it in the lime sludge hydraulic lime sludge pallet machine. We have developed that machine, and we have supplied to Nani paper mill that lime sludge, and the pallets made were as hard as limestone. It is not limestone, but it was equivalent to limestone. It has enough hardness, compactness, and its dryness was approximately 65% average. And this lime sludge pallet machine or lime sludge hydraulic pelleting compressing machine you can install in the white liquor clarifier underflow also. This is the advantage of this machine. So you can replace the WLCD by this machine also, and by this machine you can increase white liquor clarifier underflow solids from 35% to 60% easily, and the investment is very low compared to if you calculate. It is only costing 2 lakh rupees per ton, because the industry, those are having high silica content. They cannot implement white liquor clarity filter. Otherwise this lime mud will tear the cloth. That is different part. We are deviating from the subject. Let to come to this factor. So these are the pellets. Pellets are dried in the open sun area for the 30 days. It automatically achieves dryness as high as 85% to 90%. Now these pellets are fed within the vertical lime kiln. It comes from baffle to baffle. Finally, it is controlled here in the heat. So there is a disc in this below this, which continuously rotate at to 1 to 5 RPM, and by flame we are burning these pellets. By this we can, by the providing a gate, we can take out the lime. This lime can be transported anywhere, crushed and reused. This is some of the system sketch for your understanding. This is the hydraulic pellet machine sketch. I will show you the actual machine also. These are the actual pellet. Bottom is the disc which is continuously rotating. We have integrated to this to rotary lime kiln also. You can integrate with it. So you need not to bother how much temperature of feed end is there. If it is increasing more than 240, you do not need to bother, because in earlier case, if temperature is increasing more than the 240 degrees, it is a big concern, because the gases are going directly to the ESP, and higher temperature gases is not acceptable in the ESP. It should be in between 140 to maximum 220 last. Eh? Well, it is like complete, sir. Almost complete. So, the line fed to rotary line clamp, if the line fed to the rotary line clamp has 4.5% silica, which is almost means 8.5 silica in the product, means it get associated with calcium oxide to form calcium silicate. So, if you want to have high purity of lime, you must have lesser silica, as less as possible. 1% is the optimum. If you bring anyhow 1% silica, it is best. Hypothesis: state-of-art vertical line gives variable retention time. You can reduce and increase the retention time also. You can integrate number of vertical line in series. These are other information which earlier I have mentioned. Every paper mill requirement for 52, even 700. Means this is the value earlier. This is the earlier data. How much you can cost you can reduce per ton of paper. If you operate line kiln at higher efficiency, means you are producing less CO2. Means you are working toward a goal which is the lesser emission or climate change. This is why all the presentation and the new concept. But it is not installed, but we are in the talk with the very number of the mill to why not to come forward in this direction. And this can be a thought of importance. This is all. Thank you. Have a good day.